Alright, so we're starting a new unit called Conservation of Energy. And you're going to see some similarities, and we're also going to revisit some of the ideas that we studied in the last unit of conservation of mass. So the main standard that we're focused on is energy can be transformed or transferred, but is never gained or lost. And the I can statements that this set of notes are focused on explain the law of conservation of energy, and describe the difference between and give examples of energy transfers and transformations. So what does that mean? Well, first let's talk about what energy is not. Energy is not a thing. Lots of students have misconceptions that energy is something that has mass or volume and exists in, it's like an object. And that's not true. It's more of an abstract thing. So it is defined as the ability for something to do work. And in order for any object to change or for something to happen to it or for it to move, energy has to be involved. And you can't really truly understand animals or biology, physics, chemistry, electronics, volcanoes, any field of science, engineering, or economics without understanding energy. It's part of every aspect. What is work? In the definition of energy, we use the word work, the ability to do work. So what is work? Well, we think of work as doing our homework or building a deck. But in the scientific definition, it is when a force moves an object over a distance. So therefore, me sitting here making this video, while it is related to my work at school, it is not part of the scientific definition of work. Now, in the definition of work, the word force came up. And you'll be dealing a lot with forces next year. But basically, you just need to know the definition of force this year, and it is a push or a pull. Connecting to what we have already learned. We talked in the last unit about the conservation of mass. And the law states that matter can change both physically and chemically, but the amount of matter will always be the same. So when we talked about physical changes, an example of a physical change is something changing from one state of matter to another. So what causes this? Well, it is a change in energy, thermal energy to be specific. In order for a solid to change to a liquid, we would have to increase the thermal energy. And we usually view that in a temperature increase. Chemical changes. What causes the matter to change in a chemical reaction? And it is the movement of electrons, the sharing and stealing of electrons between atoms. So again, that is a form of energy. Law of conservation of energy. It also states that energy cannot be created or destroyed, but it can change. What do they mean by change? We're talking about transferring energy or transforming energy. And while they are very similar concepts, there actually are some differences. So let's look at these two words. Transfer means that one type of energy is being transferred into another object. So basically, the same form of energy is going to leave one object and enter into another object, so the energy level will decrease in one object and increase in another. An example is light energy shining through a window. It's not changing energy forms, it's still light energy, both outside and inside, but it has changed mediums along the way. Transform. That means that one energy is changing to a different type or form of energy. An example of this is down below in the diagram of a circuit. So we have chemical energy in the battery, transforming into electrical energy as it flows through the wires, transforming back also into light and heat energy inside the bulb. Now, when we talk specifically about transformations and transferring of energy, this unit, we're going to mainly be focused on kinetic and potential. Those are the two main types of energy, and the other forms of energy fall underneath one of those categories. Later in the year, when we talk about energy again, we're going to be looking at transformations more specifically, like in the diagram on the last page, where I talked about specific forms of energy transforming from one to another. So what is kinetic energy? Kinetic energy is the energy of motion. You should have learned that last year. So you should have a good basis of what it is, and now we're going to be applying it to transformations. Kinetic energy comes from the Greek word kinetos. It means moving. Now keep in mind, when we're talking about an object moving, some of those objects you can't see with the human eye. It might be subparticles, might be atoms, but they're all really tiny. The amount of kinetic energy an object possesses is equivalent to the force to get that object to move. And the kinetic energy of an object is dependent on two factors, the object's mass and the object's velocity. And as both the mass increase and the velocity increases, so does the kinetic energy. Let's talk about mass. In the top diagram, I have a picture up here of a bowling ball and a golf ball. If we are to compare the masses of those, the amount of matter in the bowling ball is greater than the amount of matter in the golf ball. And if we were to push those along a track towards pins, we have to think about which one would do more work on the pins if they were going at the same speed. So we have two different masses, but we have them going at the same speed or velocity. And I think we all know that the bowling ball would do more damage to the pins as far as getting them to move over a distance. Velocity, you need to know, is the speed of an object in a certain direction. I think you did a lot on last year on motion, so this should be fairly easy concept for you. But think about the work two identical bowling balls now do at different speeds on pins. We move one really slowly versus we move one really fast, being the same mass, both of them. One's going to do more work on the pins than the other, and probably the one that's going faster speed. Kinetic energy form. Electrical energy, light energy, sound energy, and thermal energy are the four kinetic energy forms. And in your notes, I really wanted you to focus on the moving words because that just helps remind you of the definition of energy. So here I have all these diagrams of the four types, and it's very important to understand that most of the energy, or the energy that we have on Earth, comes from the sun. So it actually comes to us in the form of electromagnetic energy, and it's transformed into several other types of energy. This diagram over here I like because thermal energy, a lot of times we think about temperature, and while there is a relationship there, thermal energy really has to do with the particle movements within an object. Potential energy. So what is it? It is stored energy. It's also the energy of position. So you kind of have to think about both definitions. And there are four types of potential energy that we'll be talking about, and one is gravitational potential energy. Gravitational potential energy is due to the height above Earth's surface and the mass of objects. So as the height increases, maybe a kid is going up the steps of a slide, then that kid's height above the Earth's surface is increasing. Well, so does his potential energy. So his position above the Earth's surface is making his potential energy also increase. As mass increases, so does the potential energy. So if you have two slides right next to each other, and you have a 2-year-old and a 12-year-old both climbing up the ladder to the same height, the 12-year-old is going to have a lot more potential energy because the mass is significantly more than the 2-year-old. Another form of potential energy is elastic potential energy, and this is due to an object either being compressed or stretched. So compressed is when things are pressed together, stretched is when they're pulled apart. An example of this would be a spring or a bow, an arrow, where you're pulling back. A rubber band also when it's being stretched. Chemical energy, the energy of a compound that changes as its atoms are rearranged. So that has to do with those electrons being shared and stolen and bonds being broken and reformed. And then nuclear energy is the energy that comes from changes inside of the nucleus of an atom. So here's just a basic concept map, but it shows that the sun is going to be giving us electromagnetic energy, okay, and that energy can then be transformed into one of these kinetic forms of energy, but it also can be transformed into potential energy forms. Mechanical energy. Mechanical energy is the total energy that an object possesses. So when you hear the word total, you should think also sum or addition. And so here we have a basic formula. And by the way, we will be working with a lot of formulas in building a roller coaster. And here's one of them that you'll be considering. But mechanical energy is just the potential energy plus the kinetic energy equals the mechanical energy. And notice that I've been abbreviating. You're welcome to abbreviate in your notes or on informal assignments. But when it comes to formal assignments, please make sure that you do write out the words potential, kinetic, and mechanical energy. Not every object has potential energy. Not every object has kinetic energy. But every object possesses mechanical energy. Because even if you're adding 0 potential energy to 5 joules of kinetic energy, you're still going to have a mechanical energy of 5. All objects possess energy. So there's not an object that doesn't possess any energy, even if it's only in the form of thermal energy, which is the random movement of the atoms that make it up. Or chemical energy from things that it has consumed. So we said that the law of conservation of mass is always true. Is this one always true? Or are there any scenarios that make it not true? And the answer is yes, it's always true. When energy is measured or observed, it is usually in an open system. Having a closed system for the law of conservation of energy is rare. And if you think back to when we did the Alka-Seltzer lab where you had the little glass bottle with the black screw-on lid, in the first part of that lab, you put the water and the Alka-Seltzer into the bottle and you screwed on the lid with the plastic wrap really tight. And we kept it closed while the reaction happened inside. So for as far as when we're talking about mass, that was a closed system. However, because it was glass, there was some energy that was coming into that system, and that was light energy. So therefore, while it was a closed system for the law of conservation of mass, it is not a closed system for the law of conservation of energy. So a lot of times, even more so than the law of conservation of mass, this law seems false, but it has never been disproved, and that is why it is called a law. Therefore, some of the energy may transfer or transform in or out of an object, but the amount of energy will always remain the same. Now here I added a site down at the bottom, and basically it just takes you to a website that will help you review the forms of energy, and this will come in handy as we talk about energy throughout the year, but also towards the end. Here is the website, and you can check that out, and you see that there are lots of things you can click on the side and brief overviews of renewable energy resources and non-renewable energy